Hello students, myself Borude Usha from Maharaja Shivaji Shinde Mahavidyalaya, Srivanga. Today we are going to see the next point from chapter number 6, Superposition of Waves of 12th Science. So, at the previous lecture we had seen what happened when there is the vibration of air column in a pipe closed at one end. We already had seen when there is a pipe closed at one end, only odd harmonics are present. Okay, and after that, when pipe is open at both ends, दोन्ही साइडला जर पाईप ओपन असेल तर तिथे व्हायब्रेशन्स कशा पद्धतीने क्रिएट होतात. Where is the formation of nodes and antinodes? Already we had seen that there is the formation of antinodes where there is the open end. That means there are the maximum number of air molecules or the space for the change of the phase of the particle. That means if there is the compression which is incident at the open end, then the reflection of compression is the rarefaction. If the rarefaction incident at the open end, then rarefaction reflect back as the compression. Okay, and by interference of these two or superimpose of these two waves, there is the formation of a wave. That is nothing but stationary wave, which is in the form of number of loops. Since this incident wave and reflected wave both interfere with each other, will get the wave that is nothing but stationary wave. So how there is the formation of nodes and antinodes. At first consider a pipe having length L, first mode of vibration. Since this is the pipe which is open at both ends, if you kept here a tuning fork with vibrating frequency, then what happens? The waves travel inside the pipe. Since there is no closed boundary, but still there are the walls of the tube, then due to this there is a denser medium, or due to this there is the reflection and there is the formation of stationary wave. Where there is the opening, then that time there is the formation of antinodes at the open end here, and another one wave which is in this way. At both the open ends there is the formation of antinode, and here is node. The length is L. After that, capital L is the length of this tube, which is nothing but L is equal to small l plus 2 into end correction. Since there are the two open ends, because of that 2 into end correction. Therefore, capital L is equal to L plus twice 2 into 3. So, what happened? The distance in between two antinodes is equal to L is equal to lambda by 2. Okay? Suppose this is the first mode. This is first mode of vibration, and in first mode there is two antinodes and a single node. Then here the velocity P is equal to L into lambda. Okay, what about lambda? Lambda is equal to 2 into L, or once again therefore N is equal to V upon lambda. But what? This L is equal to lambda by 2, therefore lambda is equal to twice L. Substituting this in above equation, we will get N is equal to V upon twice L. Equation number first. What is this? This is nothing but the fundamental frequency. This is called as fundamental frequency. Frequency of first mode. N is equal to V upon twice L. Now secondly, since this length is same, in second mode this length is kept same. Okay. Here this is suppose L, then this capital L, which is equal to what we have to do. Now in this case there is also formation of antinodes at the opening. Then what? antinode, antinode, antinode. Then here node and that means 2 nodes and 3 antinodes form at the second mode. Second mode of vibration, there is 3 antinodes and 2 nodes. So what is the length of this air column? That is equal to, see here, antinode to antinode, lambda by 2. And once again antinode to antinode, lambda by 2. That means lambda by 2 plus lambda by 2. 2 lambda by 2. 2 lambda by 2. 2 get cancelled. Therefore, L is equal to lambda. Consider here lambda 1. Now, in this case, what happened? N is equal to or V is equal to N1 lambda 1. Therefore, N1 is equal to V upon lambda. Therefore, N1 is equal to, what is the value of lambda 1? That is equal to L. Therefore, V upon L. By rearranging, what N1 is equal to 2V upon twice L. By multiplying and dividing by 2 with this equation. What is this? This is the fundamental frequency, that is N. Therefore, N1 is equal to twice. What we got? Frequency of the second mode, N1 is equal to 2 into fundamental frequency. Okay, this is the frequency of second mode. Since this is first harmonic, what it called as first harmonic. Now this is called as the second harmonic. What is this? This is called as the second harmonic. Okay, this is second harmonic as well as first overtone. What is overtone? Overtone is nothing but the frequency which comes just after the fundamental frequency is the first overtone. Okay. Now thirdly, in third mode, consider this length is constant. That means in this way, this is small l, this is capital L. Since capital L is equal to small l plus 2 into E. Now in this case, there are the formation of in this way. We have to show this same. This one is bigger. Suppose now, okay, in this way. Here is also antinode. Here is node. In this way, antinode, node, antinode, antinode, node. 1, 2, 3, 4, 5 antinode and 1, 2 and 3 nodes. Okay. So, what is the distance in between them? Now consider antinode to antinode lambda by 2. This one lambda by 2 and this one also lambda by 2. So, here L is equal to 3 lambda 2 by 2. 3 lambda 2 by 2. Therefore, here lambda 2 is equal to twice L by 3. What about frequency? In this case, this is third mode. This is third mode here. V is equal to N2 lambda 2. Therefore, N2 is equal to V upon lambda 2. Okay. Now, substituting value of lambda 2, which is equal to V divided by twice L by 3. Therefore, 3V by twice L. Okay. So, N2 is equal to 3V by twice L. What is this? This V upon twice L is nothing but also fundamental frequency. Therefore, N2 is equal to 3 into N. That means, in this case, or in third mode of vibration, we got N2 frequency is equal to 3 into fundamental frequency. What is this? This is third harmonic. This is called as third harmonic and second overtone. Okay. Therefore, where pipe open at both the ends, we got the values of frequencies in such a way n, twice n, thrice n and so on. That means we can write in this way p plus 1 into n. So frequencies p plus 1 into n, where p is equal to 0, 1, 2 up to so on. So what is here? All harmonics are present as well as overtones are also present. So the bits produced due to the pipe open at both ends gives all the harmonics, and because of that we can hear the more good sound than that of the pipe closed at one end, because there is no absence of any harmonic in this case. So we can hear the more precious sound due to the pipe. Also we can say that the fundamental frequency in a closed pipe is double than that of the frequency of pipe open at the frequency of pipe open at both the ends is double than that of the frequency closed at one end. Since what happened in closed end, what we had seen? We had seen that V is equal to P, n is equal to P upon 4L, and in this case n is equal to P upon twice L. So this is twice the frequency of pipe closed at one end. Okay, so this is more precious. Now next one more, that is practical determination of end correction. Next point from this is the practical determination of end correction, which is measured in E. E is equal to 0.3 into D. E is equal to 0.3 into diameter. This is the end correction. Now in case of pipe closed at one end, P is equal to 4 into N1 L1. Or frequency N1 is equal to P upon 4 into L1. Therefore 4 N1 L1 is equal to 4 into L2. But what is L1? L1 is equal to small L1 plus E, and L2 is equal to L2 plus E. Therefore N1 plus N1 E, which is equal to N2 L2 plus N2 into E. Okay. By taking this one at the one side and this one to the another side, then what we have to do here, that is N1 L1 minus N2 L2 is equal to N2 minus N1 out of bracket E. Therefore end correction E is equal to N1 L1 minus N2 L2 divided by N2 minus N1. Okay, or we can write this in this way also, that is E is equal to, if we take this to this side, this to this side, then N2 L2, if we take this here, this to this side, if we take this to this side, minus N1 L1 divided by N1 minus N2. Okay, we can write in this way end correction. We can find out with the help of this formula. Now in case of a pipe open at both the ends, what we had seen, P is equal to twice N1 L1, which is equal to twice N2 L2. Therefore N1 L1 is equal to N2 L2. But N1 L1 means small L1 plus E, which is equal to N2 into L2 plus E. Therefore N1 plus N1 E, which is equal to N2 L2 plus N2 into E. Once again N1 L1 minus N2 L2 divided by, since here we keep this as it is, this N1 to this side, therefore N2 minus N1, which is equal to E. Or we can write this in this way also, that means N2 L2 minus N1 L1 divided by this here and this one to this side. Therefore, N1 minus N2 is the next one, that is nothing but end correction. These both quantities having the same values. This is the end correction used to determine by the